All right, in this lesson, our goal is to be able to convert between radians and degrees. So given an angle measure in degrees, what is that in radians and vice versa? And so as we work through it, I want you to think about what's the conversion rate between radians and degrees. So how are they connected? All right, this first part is going to be pretty simple for you because we've been doing so much work with the unit circle so far. But we're going to talk about angles in standard form. So standard form always starts from 0 degrees and it works counterclockwise. So over here it talks about an angle on the coordinate plane is in standard form when the vertex is on the origin and one ray lies on the positive x-axis. So what it's talking about is the vertex of the angle is here at the origin, and one of the rays, so the one side, lies on the positive x-axis. So that's talking about this piece right here. It's pointing towards the 0 degree angle. The ray on the x-axis is called the initial side. The other ray is called the terminal side. So when I look at this, this is the initial side, and this is the terminal side. Counterclockwise rotations result in positive angle measures, and clockwise rotations result in negative angle measures. And one full revolution is, of course, 360 degrees. So that is just some terminology and some information that you need to know. So as I move counterclockwise, my angles are positive angle measures. And as I move clockwise, so if I start at 0 and move this way, I'm going to show that that's the movement by showing a negative angle measure. So let's go ahead and let's see what that looks like on a coordinate plane. All right, so I see that we're talking about a 75-degree measure, so that is positive. And when I think about where that's going to be, I know this is 0, this is 90, so it's going to be somewhere between 0 and 90, and it's going to be closer to 90 than it is 0. So it's going to be something like this, and it's this movement right here. So from the initial side to the terminal side, that would be my 75-degree angle right here. All right, so this next one, I see that it is negative 160 degrees. So what that means, instead of starting at my initial side and going counterclockwise, negative tells me to go clockwise. So I'm going to go this way, 160 degrees. So when I think about this being, so one whole rotation is 360 degrees, and I know half would be 180. When I think about negative 160, it's almost a half rotation. So it's going to be a little bit less than a half rotation in the clockwise direction. Another way I could think of it is if this is 360 degrees, and I'm going in a negative direction, I could take 360 and subtract the movement that I'm going, because I'm going in a negative direction, and that gives me 200 degrees. So I could think of it from a positive standpoint. I'm going to where the angle is 200 degrees, because negative 160 is going to be the same as going positive 200 degrees. So that's going to put me about right here. Now that's not exact, but this would be a negative 160 degree rotation. All right, so for number 3, it says to go 430 degrees. So I know that I'm always starting from the initial side being on the positive x-axis. And 430 degrees, so it's positive, so I'm going to go counterclockwise. And if I think about where 430 degrees is, that's greater than 360. So it's going to be one whole rotation and a little bit more. So to find out what little bit more it is, I'm going to subtract off the 360 degrees that one rotation would be, and I get 70 degrees. So really, 430 degrees and 70 degrees are going to put you in the same position, because I'm going from 0, 360 degrees, and then I start back over at 0 once I've done that one rotation, and I need to go another 70 degrees to get to 430 degrees. So it's greater than a 360 degree rotation. So that's going to put me somewhere there. Now obviously that's not perfect, but I'm going to show that I've gone around 1 full time, and then a little bit more to get to that 430 degrees. All right, so this is going to be a really important skill as you move into pre-calc next year, radians and degrees. So being able to convert from radians to degrees and from degrees to radians. So if you will recall that we've talked about 360 degrees. So when I think about 360 degrees, I know that's 1 full rotation. So how many radians is that? I'd like you to pause the video and see if you can remember how many radians are in 360 degrees and how many radians are in 180 degrees. So hopefully you remembered that 360 degrees is 2 pi radians, and normally you would put the pi sign in there, but I can't type that in. And 180 degrees is just pi radian. It's just 1 pi radian. So this is our kind of formula that we use when we're converting from degrees to radians and radians to degrees. And so when I think about here, I want to go from degrees. So I'm given an angle, say it's 70 degrees, and I want to know what it is in radians. So this is the formula that I use. So I want degrees to cancel. So the relationship is that pi radians is 180 degrees. That's just what we talked about up here. 1 pi is the same as 180 degrees. So if I want degrees to cancel, I want to put the degree measure on the bottom, because whatever this measurement up here, 70 degrees, will then cancel with the 180 degrees. So I want those labels to cancel, so I'm left with radians. And then over here, it's just the reverse. So if I have radians and I want to go to degrees, I'm going to put the radian conversion. So this is just the conversion rate. I'm going to put the radians on the bottom so that those labels will cancel and I'll be left with degrees. So let's go ahead and let's look at this in action. All right, so my instructions for this first set of problems is I can see that they are all given in degrees. So obviously I want to convert to radians. So I recall that the conversion connection is 180 degrees is the same as pi radians. So I'm going to set this up. All right, so I'm going to set this up as 30 degrees, so the value that I'm trying to convert, and I want my degree signs to cancel. So the only way that they'll cancel is if there's degrees on the top and in the bottom in the numerator and denominator. And so I know the connection between radians and degrees is that pi radians, so 1 pi, is the same as 180 degrees. So when I go to multiply, that's all I'm doing, is these degree signs are going to cancel, and I'm going to have 30 pi radians over 180. So all I did there was I multiplied. So once those degree signs canceled, I just 30 times pi is 30 pi, and then I have my label radians over 180, because I just, essentially this is like over 1. So 1 times 180 is 180. And then I simplify. I could have also simplified over here and seen that 30 and 180 can also cancel, but if you don't see that, you can just come right over here and do it. So when I think about 30 and 180, the largest number that can go into both is 30, and that just gives me pi over 6 as my answer, which, if you recall back to all the work we've been doing with the unit circle, 30 degrees is pi over 6 radians. So when I graph those on the unit circle, those are the same. So go ahead and pause the video, and I'd like you to try number 5 and number 6 on your own. Now, this one is going to be no different, same process. I'm just using a negative angle now instead of a positive angle. All right, so number 5, you should have gotten 5 pi over 6, which when we think about 150 on the unit circle, we've gotten 5 pi over 6 before. And then negative 220 should have gotten negative 11 pi over 9. So if you have any questions about how I got those, please make note of that and put that in your notes right now. Otherwise, we'll move on to radians to degrees. All right, so this is the exact same process, except for now I'm going from radians to degrees. So given that I have 4 pi over 3, what is that in degrees? So this is in radians, so I want my radians to cancel. So when I multiply this by my conversion rate, I want the radian value on the bottom. So when I think about the connection between radians and degrees, I know that 1 pi radian is equal to 180 degrees. So I'm going to set this equation up like this. So I've got 4 pi over 3 radians, which was given, and I want those radians to cancel, so I'm going to put the conversion rate with the radians in the bottom. So pi radians are the same as 180 degrees. So my radians will cancel. And you do not have to put in radians or degrees every time. I'm just doing that so I remember how to set it up. So once you get the hang of it, you should be good. All right, so I've got 4 pi times 180 and 3 times pi. I also notice that pi and pi can cancel because I have one in the numerator and one in the denominator. If you don't see that, you can multiply through and then simplify. I just like to simplify first. It makes it a little easier. I also notice that 3 and 180, 3 can go into 180 60 times. So I can cancel that. And so I end up multiplying, my final answer is I end up multiplying 4 times 60. And then in my denominator, I don't have anything else, and I have those degrees left. So 4 times 60 is 240 degrees. Now, if you're not one that likes to multiply or to simplify and then multiply, I could multiply these out first. So I would do 4 times 180, and I get 720. Pi over, and then 3 times pi, which is 3 pi. So then from here, I can simplify 720 divided by 3, and I get 240, and then the pi's cancel, and so that still leaves me with 240 degrees. So go ahead and pause the video, and I'd like you to try number 8 and number 9 on your own. All right, so for number 8 and 9, you should have gotten negative 25 degrees and 315 degrees. So if you have any questions about how I did that or where I got any numbers, please make sure you make note of that. And we will do some more practice with this tomorrow in class. Good job.